Why do Mercury and Venus do not have moons? Creating the solar system, 9 planets, more than 120 moons, millions of asteroids and other stony objects, and countless comets all revolve around our sun. The solar system, which is our home in this huge cosmos, is made up of all of them. Mercury is the planet that is closest to the sun, followed by Venus, Earth, and Mars. The inner planets of our solar system are what we refer to as these planets. Each of the planets in our solar system is distinct in an unexpected way and has a distinctive defining trait. Venus suffers extremely corrosive sulfuric acid rain, while the Earth supports life and allows it to flourish. In our solar system, each planet has a satellite that surrounds it in a set orbit. These satellites are like miniature worlds that encircle each planet. Kepler's laws of motion can be used to distinguish and recognize the orbits. The celestial body that is closest to Earth is the Moon. The only naturally occurring satellite is it. A satellite's parent planet is often significantly smaller than a satellite. There is just 1 satellite on Earth, 2 on Mars, and over 80 on Jupiter, including Ganymede, the biggest satellite in our solar system. More than 8 moons orbit Saturn. Neptune has around 14 satellites, compared to Uranus's 27. Pluto, a dwarf neighbor, has 5 satellites orbiting it as well. Surprisingly, Mercury and Venus, the first 2 planets in our solar system, don't have moons. Still, why? Why are the first 2 planets the only ones that do not share this defining trait? And how were the satellites created precisely? This video will provide a thorough analysis of satellites and the factors that influence their creation. Before we go any further, please like, subscribe to our channel, and click the bell symbol for more fascinating subjects like these. How do satellites work? Before moving on, let's talk about what satellites are and how they are created. Spoiler alert, the birth of the solar system and its aftermath are the key to all of our solutions. Satellites are celestial objects that orbit a planet or dwarf planet, which is often much larger than them. However, they can also circle big, heavy astronomical objects like planets and pieces of enormous asteroids. Any astronomical entity with a mass that is roughly 1,000 times that of its parent planet and that has a known orbit around it is referred to as a satellite in scientific jargon. Not to be confused with the satellites Elon Musk and others are putting into orbit to improve your Wi-Fi. Those satellites are very dissimilar to the one we've been talking about. How do satellites develop? Theory of giant impact and capture. These satellites were created as a result of the formation of planets. There are primarily 4 ways that it can happen, although there are undoubtedly many more. We might discover more ways of their formation someday. The giant impact, or the collision of 2 or more huge celestial bodies, can result in satellite formation. You may be familiar with our moon as the most well-known example. Numerous ideas anticipate how our moon was created. The moon was formed as a result of an Earth-Mars-sized planet collision that ejected material into space that eventually gathered under the influence of their gravitation to form our moon, according to the most plausible scenario. Theoretical explanations for how our moon formed, however, will be covered in more detail later in this movie. The capture theory is a different explanation for how satellites develop. Thomas Jefferson, an American astronomer who was researching the moon formation ideas at the time, suggested this theory. According to this idea, large planets have the ability to grab small objects that resemble planets and satellites but were actually formed somewhere else. Since they lack the bulk to maintain a spherical shape, the majority of these satellites are asymmetrical objects. Saturn's moon Phoebe is said to have been captured by Saturn at one point. How do satellites develop? Theory of condensation and fission. The fission theory, or the wear and tear theory, is another explanation for how satellites arise. According to the angular momentum conservation hypothesis, a component of the planet may be torn off during the early stages of planet formation, when the planet was still in a molten state, if it rotates at a very high angular velocity. This could result in the production of a small planet-sized satellite. The condensation theory, also referred to as the co-accretion theory, is another approach to satellite formation. A significant amount of rocky mass is also left behind as a byproduct of the formation of huge gas giant planets like Saturn or Jupiter. The self-gravity of this leftover mass may also cause it to adhere to one another and eventually merge, resulting in the development of satellites. Similar to this, satellites can also develop in the early phases of the formation of the solar system when extra gas and dust combine under the effect of their gravitation to form a tiny planetary satellite. Conditions essential for satellite stability. In accordance with the energy equation and Newton's laws of gravitation, satellites orbit their parent planet in fixed circular orbits. Information about Mercury plus why is Mercury devoid of satellites? The smallest planet in our solar system, Mercury, is only little bigger than the Moon. It is also the solar system's nearest planet. It is called after the speedy messenger of the Roman gods, Mercury. It also holds the distinction of being the solar system's fastest rotating planet, completing one revolution in just 88 Earth days. However, was too close to the Sun for a satellite to maintain a stable orbit around it. In this area, the Sun's gravitational pull is so powerful that any satellite circling Mercury would be swallowed up by the Sun in a matter of hours. So, at any point in time, did Mercury have a moon? Well, the result would remain the same even if it did. The orbit of Mercury's satellite would become extremely unstable due to the Sun's strong gravitational pull, which would eventually cause the satellite to be swallowed by the Sun and destroyed. Due to its small size in relation to the Sun, Mercury would be unable to generate a gravitational field strong enough to keep its moon in a constant orbit around it. Therefore, having a satellite in orbit around Mercury would be the most difficult task of all the planets. According to the capture idea, a satellite that came close to Mercury and was pulled in by its gravitational pull would eventually be drawn into an orbit around the Sun and eventually be swallowed up by it. If a satellite is too far from Mercury, taking distance into account, it won't have a stable orbit around it. On the other hand, if it is close to Mercury, it may collide with it or strike the Sun. For Mercury, the end effect will always be the same. Mercury continues to orbit the Sun alone and without a companion as a result of fate. We're always here for you, Mercury, of course. Venus's description plus why is Venus devoid of satellites? Does Venus have the same justification then? Is the Sun's strong gravitational pull on Venus too strong? Venus, the second planet from the Sun and third brightest object in the night sky, is named for the Roman goddess of love. It claims to be the hottest planet in our solar system as well. Among all of the planets, Venus is one of the rarest examples. Because no cosmic leftover was able to reach the belt where Venus and the Sun's gravitational forces were balanced, Venus does not have a natural satellite in orbit around it. It's possible that Venus once had a moon as well. However, Venus was nearer to the Sun than Earth, which led to the moon straying from its original orbit and settling somewhere else. Due to its close proximity to the Sun, Venus would be exceedingly unlikely to have a moon orbiting it, making the orbit of the satellite the precise location of gravitational neutrality between Venus and the Sun. This was made possible by the extra slim band. As a result, the Sun has a significant impact on the likelihood that Venus has a satellite in orbit around it. How did Earth manage to support satellites? Even our planet Earth had a satellite, which was fortunate. Our moon's survival was due to a number of things. The biggest factor of all was Jupiter's presence. Our moon would have been pulled into an orbit around the Sun and slowly consumed by it if it weren't for Jupiter. The Sun is still close enough to our planet for tides to reach the height of a building. However, as we move away from Venus, the Sun's influence steadily fades. The sole natural satellite of Earth is the Moon. It is believed to have originated not long after Earth itself, at around 4.5 billion years ago. The most frequently accepted theory regarding how the moon formed is that a Mars-sized object crashed with Earth, causing a portion of our planet's mantle to be launched into space, as we described earlier in this video. The moon was created after this material came together. How did the Earth hold its satellite in place? The newborn moon was dragged into an orbit around Earth by the attraction of gravity between the two bodies. The moon has stayed largely constant since then, despite the fact that our Earth has undergone significant change. Though it is believed that the moon's orbit has widened considerably over time, it will still revolve about Earth for many billions of years to come. The stability the moon provides has allowed life on Earth to develop and advance. Without our devoted satellite, everything would be rather different. Conclusion: we would never be able to confirm the true causes for the first two planets' lack of moons, regardless of the reasons. Is it still possible that Venus or Mercury will have moons? If it is possible, how is it done? What would happen if one of them was hit by a big asteroid right now? Will it then receive a satellite, just as the Earth did? The cosmos is quite big. Humans are just unimportant occurrences with a sense of judgment. The adage judging the events of our universe based on simply noticeable facts would be just like inspecting a teaspoon of ocean water and remarking on the existence of sharks and other huge creatures lurking in the sea is well known. Continue to follow us, like and subscribe to our channel for more updates. It encourages us to continue publishing intriguing subjects like these.